Hi, question number 1. The diagram shows a closed pegs. The closed pegs is here, we can see, and that the height is this one here, that space, okay? So which device is suitable for obtaining an accurate value of the height of the closed peg? We're not going to be able to measure this with tape or meter ruler. Measuring cylinder, no, so a micrometer would be the answer. Okay, so now, which set of quantities are all vectors? A chemical energy mass is not a vector. Extension, force, gravitational potential energy. Extension is not a vector. Weight, kinetic weight is not a vector. So we have acceleration, displacement, and velocity. Answer is going to be A. Question number 3. The graph shows the motion of a cyclist during a ride for the last 14 seconds. Now we can see the distance traveled here is 28 meters, and also the time taken is 14 seconds as stated over here. So now we want to find the average speed, and we understand that the average speed is basically the distance divided by the time. And so we have a distance of 28 and divided by 14, and that turns out to be 2.0 meters per second. So our answer is going to be A. Question number 4. The diagram shows how the velocity of a train varies. Okay, now we understand that this is the positive velocity here and negative. So over here in this region, the train is moving in the opposite direction. Opposite direction. So what's going to happen is which sections of the graph shows where the magnitude of the velocity of the train is decreasing. We understand, you can see the velocity is coming down here, so that shows here a decrease. And because we're moving in the opposite direction, so this one now is going to, instead of decreasing, this is an increase, and this one is decrease. This section here is showing a decrease in the velocity. So we're looking at P and R. So the answer is then B. Question number 5. A metal disc is squeezed in the jaws of a vise. Now we see the metal disc over here. And which property of the metal disc is unchanged when it is squeezed? Now this is being squeezed. Now we understand that the mass here, okay, is going to remain unchanged because the mass is the amount of inertia in a body, so the mass is unchanged. Why? Because it doesn't change it. You can squeeze that, it's going to, the shape of it's going to change, but the mass remains unchanged. Okay, so the radius is going to change, and the distance between the atoms is going to change. The forces between the atoms is going to change as well. So the answer should be A. The gravitational potential, the gravitational field strength in space is smaller than that on Earth. We can see that with reference to the moon and the Earth, alright? So over here I've got the Earth, and it has a gravitational potential force that pulls objects. Now, how are the mass and weight of a satellite affected as the satellite it moves away from the surface of the Earth into space? Okay. Here the satellite is now moving away. And of course, if it comes closer to the Earth, alright, there will be a tendency that the weight is going to increase. The weight is not going to increase, but it's going to pull everything. So the mass, let's say that this satellite here, it has a mass. So the mass is not going to change anyway, because the mass is the, basically, let's say the weight, okay, the amount of inertia in that body, so mass isn't changed in my observation. But what happens to the weight? You see, as you move away from the gravitational force, the weight is going to decrease because it becomes lighter. Okay, the weight. You remember when you float in space, okay? So here we are. The mass isn't affected and the weight decreases. So the answer should be D for that question. Now question number 7. A material has density 2.4 grams per centimeter cube. So that basically means I have 2.4 grams per centimeters cube. Now 1 centimeter cube is actually 100 okay, so 1 centimeter, so we're going to convert this into meters. So we know that 1 meter is equal to 1 centimeter. So I'm looking at meters cube here. So what I'm going to say is that 1 meter cube is actually 100 to the cube centimeters cube. Okay, so now if 1 centimeters cube of is going to give us 2.4 grams okay, density, then what about 100 to the cube centimeters cube? So that's going to give us which is basically 1 meter cube. 2.4 times 100 to the cube grams. We want this in kilograms, so kilograms we're going to divide by 1000. So what we're saying is that this is 2.4, then 100 meters, 100 centimeters cube, okay, is 100, so this is 1 meter cube basically. It's going to be then 2.4 times this 10 to, 100 to the power 3 is basically 10 to the power 6. Alright, and then divide by 1000, we get in kilograms. 1000 is 10 to the power 3. So what we're saying then is this is 2.4 times, you just take away 3 from there, so that's 10 to the power 3 kilograms per meter cube. So what is 2.4 to the power times 10 power 3? It's 2.4, 1, 2, and 3. So that's going to be then 2,400 kgs per meter cube. So the answer turns out to be D. Now moving on to question number 8, let us see. An object falls vertically through the air. Now this is the object, it's falling. Now if it falls, okay, down, of course the earth is going to pull it. There's gravitational force here. Okay, so the gravitational force is going to pull the object down. Then again, it's falling against the air, against the air. Because if you fall down, then the air is going to push up, try to push the object up. So the answer should be A then for this part of the question. Basically, when I say against the air resistance, I mean this against the air, I mean the air is going to resist here, you know? So resistance, air resistance, alright? So this is the physics terms, alright? Here we are. Now for question number 9, a force F is applied to a lever at a distance of L from the pivot as shown in the diagram. So here's the pivot, here's the lever, and here's the force. Now the length D is the perpendicular distance. These are very, very important words. Perpendicular distance. Okay, between the force and the pivot. Perpendicular distance between the force and the pivot. So we want to find an expression. Which expression is the moment of force F about the pivot? The distance got to be perpendicular to the force. So, and then we have, of course, C as the answer. The force multiplied by the distance here is the moment of the force. Now for the next question, we've got question number 10. A rocket is launched vertically upwards. Alright, so a rocket is launched vertically upwards by a constant force from its engine. All the force is coming from here, the engine. Now how much work done? Remember, work done is equal to the force, the net force I would say, multiplied by the distance that it's traveled. Okay, so we need the net force. And so to find the net force, we're going to take the force from the engine, okay, minus the force acting by the air, which is 0.1, and the weight of the rocket as well. So that's going to be then 3.5, take away 0.10, and then take away 1.9, and we get net force. So that's going to come to 1.5. And because we know the formula, force multiplied by distance, the distance, how much work done on the rocket is used to increase its speed in the first 100 meters. That's our distance here. Okay, so then it's going to be 1.5 times 100. Okay, so that's what we use this formula here, and so that's going to become 150 million joules. It's given in million here. Okay, million newtons now, so that's the answer should then be A. Question number 11 is much more of a very straight question here. Which equation is used to calculate the efficiency of an energy transfer? We can say that we need all the useful energy or power here divided by the total power or total energy input, output over the input. Alright, so that's going to be A as the answer. The rest of the ones is wrong because this one, like, it's pretty much straightforward, I'm sure you understand the logic here, right? Okay, question number 12. We have 4 objects of different masses and they are lifted through different distances in different amounts of time. In which combination of mass, distance and time is the greatest power transferred? Now, we understand that we need some work done here. And what is work done basically? So work done is given by the gain in potential energy divided by the time taken. So the gain in potential energy, you've learned that is mgh, okay, the mass times the acceleration due to the force of gravity times the distance, which is the height over here, divided by the time. So if we were to calculate for A, so A is going to be equal to, then we have a mass of 2 times the 9.8 okay, gravitational force, then times 2, the distance here is 2 meters, and so we're going to divide this by 3. So for the first one, we're going to get 13.06. So in the same way, we're going to do all of them. So it turns out that the answer is then going to be C, because that's the greatest power here, 26.13 watts. Compared to the other ones, the least is this one, 13 point, which is 8.06, and yes, the answer is then C. Okay, for now, let's see. Just one moment. My pen is not moving here. Just one moment. Yes, it is fixed now. Okay, let's take a look at this question here. Air at a pressure of 1.0 times 10 to the power 5 Newton meter per square per meter square is trapped into a container by a piston. So maybe this one here could be said to be our P1 V1. And we know that P1, okay, P1, rather P1, okay. V1 should be equal to P2 V2. And now it's trapped into a container by a piston. A force is applied to move the piston down into the container. The temperature of the air remains constant. Temperature of the air remains constant here. So this formula applies. And the distance between the base of the container and the piston decreases from 1.8 to 1.5. I mean 0.18 to 0.15. So basically what we're saying, we want to, what is the new air pressure? Now, because we have P1, we want to find P2. So P2 is actually P1 V1 divided by V2. And if we were just to substitute the values into this, we know that the P1 is 1.0 times 10 to the power of 5 multiplied by V1, and the V1 is 0.18, and all of that being divided by 0.15, V2. So therefore, if you were to do this in a calculator, you'll come up with 1.2 times 10 to the power of 5 Newton per meter square. Right, so here where the cross-sectional area remains the same here, and therefore the answer turns out to be C. Now let's move on to question number 14. A sealed gas syringe contains a gas that is kept at a constant volume. Remember, this is a constant volume. We have a constant volume here, so the temperature, okay, will be directly proportional to the pressure. And if that's the case, if the temperature increases, the gas increases, the pressure increases. If it decreases, decreases. So we are looking at increase and increase. Basically, the answer will be range C. That's very kind of direct. You should just know your steps over here. Now looking at question number 15, the melting temperature of gold is 1064 degrees Celsius. What is the melting temperature of gold on the Kelvin scale? Now when it comes to the Kelvin scale, okay, we know that this is going to be equal to 273 plus the temperature that we have. So over here we've got 1064. So 273 plus 1064 turns out to be 1337 Kelvin. So here we are. So D would be the answer to this part of the question. Okay, I might be able to do the rest of the paper later on because I've got an urgent business coming up. So sorry for interrupting like this. Take care. I hope this has been of some help to you guys. All right, bye.